New Zealand, one of the last major land masses settled by humans, a country lost in time, boasting an astonishing diversity of landscapes and a unique South Pacific culture. A land set apart by the world's great oceans, lifted above clouds in alpine splendor, born of volcanic fire, blessed with natural abundance and youthful energy. New Zealand from above. We're in the central South Island of New Zealand, which spans a wide range of landscapes from the mountains in the west to the ocean in the east. New Zealand's diverse landscape was formed by glacial action, volcanism, and movement of the Earth's crust. As we travel from the south of New Zealand to the north, we will learn more about these astonishing processes. This is Omarama in the center of the island. It has always been a favorite location for gliding because of the thermals rising from the surrounding hills and the mountains beyond them. Omarama means place of light in Maori and is the base for pilot and alpine guide Gavin Wills. Today, Gavin's destination is Aoraki, Mount Cook. The advance and retreat of glaciers is one of the most sensitive indicators of climate change. And Gavin's passenger, glaciologist Trevor Chin, has been monitoring a group of New Zealand glaciers since the 1970s.
South Island, New Zealand is a kind of a unique setup. The Southern Alps are almost directly perpendicular to the prevailing west winds, and it's a very windy place. It's arguably the windiest inhabited place on Earth. Here at Omarama, we have dry, warm, gusty winds, which are the classic Föhn or northwest winds that we're famous for. It's a gliding mecca, really. People come from all over the world to experience it here. It's a hot environment, which creates thermals. Thermals are good for glider pilots. As you fly out of Omarama going north, an incredible array of landforms in front of you. And they're like a lure for the glider pilot. The higher the mountains, the better the lift.
Gavin and Trevor's flight path will take them over the sparsely populated Mackenzie Basin, lying at the foot of the mountains, and named after James Mackenzie, a Scottish shepherd turned sheep thief, who drove his stolen flocks of sheep to this area, then empty of human habitation. Within the Mackenzie Basin are 4 lakes: Ohau, Pukaki, Tekapo, and to the south, a smaller man-made lake, Benmore. Waitaki River once ran through this valley, draining the Mackenzie Basin. A series of dams was constructed on the Waitaki River to store water for electricity generation. "70% of electricity generated in New Zealand is from renewable sources, and hydro provides more than half of the country's energy needs. The core of Benmore Dam is a clay and gravel mixture, impermeable to water, and supported by two massive shoulders of river gravel. The dam was commissioned in 1965 and is the largest earth structure in New Zealand. In summer, snow and ice in the mountains behind the Mackenzie Basin melts. In winter, it freezes again, and the dam has been designed to handle the resulting significant changes in water flow volumes. A large workforce labored for a decade to construct this dam, living in temporary towns nearby. Today, the dam is monitored remotely, and Kelvin Jobson comes on site only when routine maintenance and checks are required. Benmore was conceived as part of an interconnected hydroelectricity generation network, designed to maximize efficient use of water from lakes and rivers in the region. The Mackenzie Basin is traversed by man-made canals, generating electricity as it flows through a series of turbines. Water moves from one lake to the next, enabling levels to be controlled and balanced. On some of the canals, fish farmers have set up salmon farms to take advantage of the pure water flowing through holding pens. Rick Ramsey proved the viability of this sustainable fish farming.
This is one of the first salmon farms of its kind in the world to actually be established on a hydroelectric canal. The major advantage for us is the very large volume of high-quality water which is arising from the glaciers. This canal is flowing at around about 120,000 litres of water a second. This is a significant river. The advantage of farming in this environment is obviously we have road access either side. It's easy to service. The disadvantage is that we're high altitude. We're at 677 metres above sea level. It gets very cold. The problem is that fish require probably around about 8 degrees to be able to grow. And in winter, we have periods where the water can get down to 5. So we have this curve where we get very, very good growth in summer, but during the winter periods, we don't get a lot of growth. We, at the moment, are hen feeding, and that way we can look at the stock, we can see what their behaviour is, we can see when they're finished feeding.
Soaring above the canals, the glider has reached its release point.
You release from the tow plane when you think you are high enough or near some lift that's going to keep you airborne. It's the glider pilot's decision when to release.
the dramatic landforms below take on new meaning when viewed with a scientific eye. Glaciers are created by snowfields being compressed to ice and drawn down by gravity, gouging a path as they slide down the mountain into the valley.
Glaciers dig holes. They're really good at it. You get these lumpy terraces on the valley sides, and there's heaps and heaps of moraine ridges, which are all on the slope of the ice. And they all enclose where the ice used to be and enclose the lake that's there now. You look out over the plains and you see all the hundreds of river channels, from old ones to recent ones, and then you go down into the incised channel for the present river, running in amongst the grey gravel. The shape of the land was formed by ice. There are actually about 30 or 40 times that the whole earth cooled and then warmed again, cooled again. Then, when the climate changes and the glacier disappears, it melts away, you get this huge lake, which is a huge sediment trap. So all your sediment that's coming from the mountains now goes into the lake. After 15,000 to 18,000 years since this process started, the big lakes are still only half full of gravel. Carry on for another 18,000 years and they'll fill completely. The aerial view is very sobering because you can see how infinitesimal our effect has been. We've just come here for a flash of time, and it's taken all these years and all these glaciations and all the uplift to create these mountains, and then we come in as though we own them.
More than 100 years ago, it was discovered the forces that shaped the land had left treasure hidden here. As glaciers advanced and retreated, they deposited rocks and minerals, including gold.
The thing about the concentration of the gold is quite amazing. The gold in the New Zealand rocks is very rarely in seams. The concentration of gold here is not very high, so you're better off getting where the river's already concentrated it from the shot over Clutha area. They had about 3 or 4 cubic metres of gold. That's one hell of a stack of gold.
In 1861, the discovery of gold in central Otago created a rush, driving the settlement of many of these inland regions. And by 1867, over 50,000 miners from all over the world were working in the gold fields.